Hello, everybody.
Hey, Brian.
Hey. Cool, I'll get started. So my talk is on logging at Braintree. As you can guess, we are Braintree. We build tools for businesses to enable them and to ease their ability to accept payments online, in addition to a number of other things. We try to ease integrations with our V0 integration, just giving you a little marketing pitch. We accept many different kinds of payment methods, so if you're interested, check us out. We are also hiring, so please take a look at our careers site if you are interested. If any of this interests you, or even if it doesn't, please check it out. Who am I? My name is Brian Lesperance. I've been at Braintree for about 2.5 years. I'm a software engineer here. In a previous life, I was actually an electronics engineer. Did that for 4 years after college, and don't think I'll ever go back. Just to give you an overview of what I want to talk about today. I'm going to go over the whys, the where and what's, and the hows, and then talk a little bit about how we use sumo logic at Braintree. So why do we log? What is the point of it? I think the 12-factor app, as controversial as some might think it is, has a very good summary as to why it's important. It gives you visibility into a running application. It's important to know what's going on in your application so you can address issues that come up, be able to debug regressions, support issues. And the way that I like to think about it was very much influenced by this Stack Overflow post by Adam Davis. I thought it was a fantastic summary on his philosophy of logging. It covers 4 main points. It covers application logging, audit logging, performance logging, and security logging. And I'll go into each of those and kind of how we accomplish those at Braintree. So the first one, application. What is this? It helps you understand what's going on in your application. It helps you understand your data flow through the entire system, a lot of your business logic. That can be very important if you have an issue. This sort of wraps into things such as like exception notifications and logging, so you can actually debug issues that happen in production. And so really what I like to think about is how can I debug issues in a code base? When I'm developing, both when I'm testing and in development mode, I like to use my logs as the tool for debugging. I don't like to just drop a debugger in there and see what's going on. I try to use the tools that I'm gonna have in production in order to see if that feature is adequate. Because really it's just as much a process as it is a product. So touching on auditing. Auditing is very important for Braintree. We need to do things for compliance reasons. That's one big part of it, but also we have a very big trust issue. We need to make sure that we are taking care of merchants' data. When you process payments, we need to know what's happening to it. If ever we think something has gone wrong, we want to know exactly why it went wrong and how we can recover from that. So that's where audit logging can come in. So those two things are critical for us. We've had to use them before in the past, and they have saved our butts, and it's fantastic. I'll talk a little bit about how we do that. Performance. A lot of people here are very concerned with performance. So we want to be looking out for regressions. We want to look out for slow integrations that we might have, just slowness in our application. It's very important, and it helps us diagnose and isolate what is actually going on, and knowing whether or not we actually had an impact. So we need a baseline to begin with as well. And security. We need to know who's doing what with their system and be able to monitor and identify those sorts of things if it becomes an issue and be notified of them. So what and where are we using these? I'm an application engineer, but I'm going to give you a quick overview of our rough stack. So I don't have a cool diagram here. It's a pretty vanilla, I'd say it's a relatively straightforward through their stack. We do have some interesting stuff going on in each layer. We have our networking layer, we have our load balancers, comes to our API application through a bunch of proxies. And then we also have our core database, which is Postgres. But we also have a number of internal services that we consume and feed information to, as well as third-party services. And this has been our stack for a long time, and it has served us very well. But because of the growth that we've gotten, we've needed to scale up the number of applications that we have. We run over 500 instances of our application, which means we have 500 services logging to our centralized logging system. And so to our proxy layers, so to some of our load balancers and our database. If ever our standbys leave the cluster, we need to know about them and understand why. That's very important. Underlying all of this, next door is syslog. Syslog ties this all together, and that's actually what we use that to collect all of our logs onto a centralized logging server, which I imagine a lot of people start off with when they move to a centralized logging system. Our syslog. So let's talk about the application. What are some examples of this? So transaction creates. We are a payment processor, so making transactions are critically important. Here I have a contrived transaction right here. We want to know when things are actually made and when they're not, because it's important for us to actually see, did it actually happen? So we give key information to give us context right away. Settlement is the process of actually capturing funds, to actually move the money out of the buyer's hands, essentially. So there we want to know with whom we're settling, as well as certain information that's important for what we do. So we have a number of identifiers that allow us to tell whether or not something was successful and what stage it's at throughout the entire time. And oftentimes the process may die, or it's becoming finicky. Out-of-memory killer starts like wreaking havoc on our application. So we want to know what is happening to our unicorn instance and why is that. This is actually a pretty normal, I forget what user queue is, but I think that's either a restart or a reload. But I was trying to look for an example of when we had to kill our application recently because of something like this, and surprisingly it doesn't happen often. I thought it would happen a little more often, 500 instances. Auditing, I kind of talked about this before. When data changes, when it modifies, we want to know what is changing, and this is critically important. So here's a contrived transaction that creates a credit card. So we have information about what was created, the identifiers about it, attributes about it, but also some good contextual information which also alludes to the security aspect of things, not just the auditing aspect of it. So a lot of these themes very much blend together, and your logging is going to hit on a number of these things. I think this is a perfect example of this. Performance is obviously huge. This is a generic Rails log. You get this basically out of the box. It gives you information about how long you spent running your templates, how long you spent querying the database, and the overall Rails time. You probably see something similar to this in any web server that you may have, proxy layers as well. This is incredibly important for us. Another big thing for us are our third-party services that we consume, such as the processors that we actually settle with. So we want to know when are they starting to slow down, and actually get some information about that, such as like what was the status code, various other things like that. We do log that stuff in metrics and stats-D, which is very helpful when we want to look at graphs of these sorts of things. But this is also important to sort of see the bigger picture in context of other things. And security. So who did what, where now, basically. Who was this? Who is this user XYZWVU? They clearly made a post to transaction here using our client library. That's the user agent that we logged. And it gives us information about where they're coming from and what they're trying to do. We also have a number of other things such as permissions and such that tell us if they are trying to access something that they're not allowed to access. But for the most part, we are able to strip away a lot of that. And it's just sort of a graceful degradation of the service for them if they're not allowed to access that. So how do we do this? What does the infrastructure look like? So if we revisit this again, like I said, our syslog underlies a lot of this. And we use that to collect all of the information from these various different services to give us information about what's going on. Because on the networking layer, we have both Linux and network appliances facilitating our networking stack. We have the load balancers we use, may be familiar with. That also is pretty important. And our services and our databases that I already mentioned. A lot of this, as you would guess, are highly available. So we either are running active-active on some of these services, or we're running master-slave on a lot of them. So an important part about that is knowing when something gets unbalancing is one part, but also when does the master need to be subbed out for the slave. So we log information about that. That's really important. A lot of our services we like to proxy through either some internal proxies that we've developed, but we are also starting to use hot proxy for a lot of that. So similar thing there, like we want to see the requests going through there, and that those all funnel through our syslog to our centralized logging server. But that is a lot of data, as you can imagine. We're not on the Twitter scale of logging data, but we're on a pretty large scale. And funny enough, we use Sumo Logic. We actually only use a single collector, I just found out, pumping all of this to Sumo Logic in order to be able to digest this information. For a while, a lot of people were able to just zcat a lot of the compressed logs that we have on our log aggregation box, but that was becoming problematic. And plus, there's a limit to what you can do with bash, enjoyably, I should say. Yeah, so I kind of mentioned this already. Syslog underlies a lot of this. Our applications, our core application especially, actually talks to a local syslog port. It talks to a local host. It doesn't actually talk to a socket. And what we've seen in the past is sockets can block. Not that interfaces can't, but it's just something to be mindful of. If you're talking to your logging services in a blocking way, that can prove problematic. We've had it kind of bite us in the past, so we've taken great pains to limit the ways it can actually affect us. Like I mentioned, syslog, we have various rules for handling catch-alls, so you don't have to worry about, oh, did I not set up a rule to catch all these, or what if I miss this, what if I'm only looking at certain alert levels. We also have primitives in our provisioning scripts to handle the client and server sides of new services that spin up, so it becomes very easy to facilitate a lot of those. So that pattern has helped us spin up new services that our main API can consume. And obviously, importantly, this is actually wrong. I thought I wrote hourly. We do not rotate daily, we rotate hourly, because we have, like I said, so many logs. And I don't think we could ever go back to daily, just given the amount of volume that we have. And so I'm going to start talking about some of the tools that we've been able to build on top of syslog that have been pretty cool. One of them is called LogBarrel. I think I have the name right. It is actually a syslog server that allows you to tail logs that are coming to it, since it is a consumer of syslog. So this allows us to basically get real-time information about our logs. You know, we could tail the logs if we wanted to, but this allows us to just consume straight from UDP. This gives us the ability to be very real-time, so we don't have to worry about graphs being delayed or interpolation problems on them. We don't have to worry about alerts possibly being delayed, Gmail rate limiting and such, and that's proved very helpful. One thing that we've baked into that, actually right here, is BTstat. It actually, so when we're doing production operations, such as deployments, provisioning, maintenance, things like that, this gives us a roll-up of the requests that have come in. It's a pretty sweet tool that some people worked on here. So yeah, I want to talk about sumo logic. Like I mentioned, been alluding to, we use it a lot. I was actually for a short period of time leading our support dev team. So there we get a lot of issues. Hey, why did this request fail? Why is my subscription in this state? Various things like, hey, where did my user go? Hey, I'm locked out of my account. How did this happen? So we've gotten to debug a lot of those situations. And I'm going to talk about a couple of the cool things that we've been able to do. So right here, this is a good example of, hey, where did my user go? On sumo logic, you can actually do some pretty crazy stuff. You can, inside this parentheses, you can parse information in order to get fields out of the log line. So if it matches that, it'll parse that out and return it to you. But one cool thing you can do is actually join across multiple sumo logic queries and then actually say, hey, give me them combined together. And then you can also pipe that to field extractions, such as like, hey, only give me these fields, and various other things. It's very powerful as you start to chain it together, but it can be a bit slow, as you can imagine. These are not relational data structures, so that can be a bit slow at times, but it has been pretty helpful to like figure out how something happened and see the totality of the actions. Alerting is something I've personally been working on. So a lot of times we get merchants being like, hey, how come I'm not receiving my webhooks? Like, what's going on? We don't have the, I would love for us one day to have an awesome logging presentation in our control panel, and perhaps that's something we can do someday. But in the meantime, like, they can reach out to us and we can try to take a look at, hey, what merchants are having problems with their webhooks, their webhook endpoints. I wrote this a while back to look for all 599s coming back from us. And this was a Tornado app, so I believe this was the connection closing down and Tornado returning a 599 for our application. And then from that, being able to parse out the endpoint URL and do a roll-up by day and seeing who the largest offenders were. And I was actually able to use this to reach out to some merchants and being like, hey, I noticed you're having troubles with your webhook endpoint. Can I help you with that? So that allowed us to be very productive, I meant to say proactive, about reaching out to our merchants. And here's kind of a quick summary of that. I've obscured the URLs, but as you can see, it kind of gives me a rundown of the past few days. And this merchant had 77,000 599s returned in that one day for that one endpoint. Pretty crazy. A lot of times those are like CI tests, sandbox integrations that they forget to turn off, or like their Heroku instance goes down and it just is like endlessly doing that, and us not being able to differentiate it being down or stale. We can't tell if we should just disable it or not. Yeah, and there are some even crazier stuff. I kind of like dove right into the intermediate level. This is probably one of the more advanced things you can do, such as trying to find outliers in information. So what this is doing is looking at a fictitious box in our production data center and parsing the Nginx logs for 422s, rolling up them into 5-minute increments and actually trying to find outliers within those 5-minute windows. So you can actually do some pretty crazy stuff to see like, hey, are we seeing a number of validation errors that are increasing based on like past requests? And here's like a rough estimate of like what that looks like. You can see some pretty interesting stuff. If you zoom in a little bit more, you can sort of see a larger outline of the, I believe that would be the standard deviation, but some of the sumo folks can correct me on that, which is pretty interesting. We haven't gotten to play with this too much since it's very much an advanced feature, and we have a lot of pragmatic uses for a lot of the basic and intermediate stuff. Yeah, so that's all I have for today. Thank you very much. I'm happy to take some questions right now. You can email me here. I'm open to be on the internet, but I probably will not respond to any Twitter messages. So that's what they call it, right? But thank you. Blue shirt?
So you mentioned about sockets locking with our syslog. Is that just something you want to keep an eye on, or do you like log to syslog in the background thread or something like that?
Dave, you might be able to answer that a little more. You worked on that directly, right?
What's the, I'm sorry, what's
So, I mean, we don't use syslog in our company because of nervousness around the blocking issue you're talking about. We want to files and pull from the files separately. But Brian mentioned that you had problems with that. Do you have any suggestions on mitigating the risk of logging directly in the socket, which could, log application activity when you're just trying to log something?
Yeah, so
can anyone hear him? I can give him the mic if not.
Yes, so can you hear me? Okay. So the question is suggestions around mitigating the fact that logging can lock. I think so. The specific case was we found ourselves in a strange state where 1/4 of our application decided to log 15,000 times per second. So you have to get into pretty egregious thresholds before, at least before we start to see problems. So I think, first of all, avoid that. But then beyond that, yeah, we can certainly try and factor out something, or basically anything we do, you want to have some thresholding in your app. Like, hey, I've done this thing 100 times in the past 10 milliseconds, maybe I should back off next time. I think that's where I would reach, but there may be other things people do.
I guess to put some specificity around what block. So we found that both the syslog, like libc, syslog call, which a lot of languages when you just say syslog, that's what it's doing. And then also writing, opening up and writing the dev log. We both had issues with blocking, which is why what Brian said, our current approach is we do UDP syslog directly to localhost 5.1 whatever the port is. Yeah, 514, and we just write the syslog to there because it's UDP, and that's presumably not going to lock down the application. Whereas both the syslog call and dev1, both we in 2 different instances had each kind of service.
But to further elaborate, even so, yeah, one of each other. Even so, if you're logging UDP locally, that's not free if you have it in a blocking kind of thing. So if you're using Tornado or some evented thing, and then you are trying to log UDP 15,000 times a second, it will slow you down.
There's another question?
I was just curious, how many terabytes a day are you ingesting in this?
I actually don't know.
Not terabytes a day. Tens of gigabytes, I don't know the number off the top of my head. It might be hundreds. She actually knows.
I thought 150.
Okay. 150 gigs a day.
It's actually a 30-day average, so some days you can be really high, and then some days you can be low.
And I have a follow-on question to that.
Yeah.
So I was curious, for your security events in particular, are you, does Sumotech, or are you employing the Sumotech capability that auto logs an event into event tracker, like a ServiceNow or something, or some ticketing agent that you can then track and rectify or come to a resolution event?
That was a really good question. Does this work?
Not really.
No, it's in fact off. I'm not a loudspeaker, so. Probably not working. Oh, hey. The question was, for security incidences, are there like ticket tracking systems that help automate some of the workflows that you might need to take care of? Do you mean more on our side or more on Sumo's side, or for reporting?
You can set up some alerts in Sumo.
Gotcha.
And are you auto-generating a ticket based on the alert?
No, to the latter part. Yeah, I can talk to a few things before I hand it off to actually one of our security folks here. I know that we do a lot of filtering of our logs. So we just have very, very crude scrubbers because we want to be overly cautious with a lot of what we log out. Since we're handing credit card information, a lot of sensitive data that not even just that, we want to be extra paranoid about that. So, if we see just like strings of numbers, we're quick to get rid of them, which can be very problematic for debugging request IDs, as you can imagine. So that proves problematic. Sumo provides a number of facilities for both ingestion filtering, as well as, I don't know what the terminology is, but basically for showing log information, you can also block that. So if you don't want to filter on the ingestion, you can filter on the viewing side of it. But as far as the tracking and ticketing stuff.
To answer your question, no, we're not using it to create any kind of like ticketing like a SIM or security management system. We have a separate setup for that. We have a product as an IDS plus SIM that we use that does ticketing and alarming and everything through PagerDuty. But so we have looked at the Sumo Ledger because that predates our usage of Sumo Ledger.
All right. Thanks.
I'm wondering, do you guys have any Docker instances in your production? And if so, do you guys have any logging strategies around Docker?
Do we have any Docker instances running in production, and do we have any strategies around that? No and no. We have, not yet is probably the more qualified answer, but we do have some ideas about what we are thinking about. Trying to use perhaps Kafka as like a stream for that instead of UDT syslogs. But we haven't gotten so far as to actually try to productionalize anything like that yet.
Thanks.
Yeah.
Do you do anything to validate that your logging is working?
So the question is, do we do anything to validate that the logging is working? We do a number of validation stuff on the application side. So we are checking that we do a lot of interaction-based testing around that. Like, hey, did we call the logger correctly? And with the data that we want to log. That's kind of where we go on that side, because we do trust the framework to some extent. However, there's some things we don't trust the framework on, such as, our core application is a Rails app. That does have parameter filtering, but we don't actually trust that it will work, even though it has never proved us wrong. So we actually run our test, open up the log file, and actually grep through that to ensure that data that should be filtered out is being filtered out. As far as from like an infrastructure level, setting up an environment, trying to grep through logs, not especially, but there are sort of indirect, implicit validations around that, such as a lot of our tooling, like BT-stat is a big one that we use that relies on our logs. If the logs broke in some way, we would know. I think Anthony and Dave, probably Downey have some stories about it breaking and tools not working, or things just like dying. We have a lot of Nagios checks, what am I forgetting, that grep through logs. So if those don't alert or do alert more, we find out pretty quickly. It has bitten us before in the past.
People spend so much time looking at the logs that no problem with our logging system lasts. I mean, people are
Yeah.
not that they don't happen, but when they do like kind of a big flow on it, no problem with the logging system lasts any amount of time because so many people are consuming the logs.
I'm happy to talk to anyone else afterwards, but I'm going to hand it back to Jared.
My name is Ryan Stelly. I'm a software engineer at Rally Health. As I got hired at Spotlight, a startup that does benefits enrollment for employers, in August of last year. In October of last year, Spotlight as a company got acquired by Rally Health, and oh, I'm sorry, I've never done this before with a mic. So Rally Health, their flagship application is a wellness and health survey that companies buy as a benefit to basically, incentivize health, eating better, exercising. So that's, and I guess look at kind of our stack and any thing we've, I guess, gone towards in the past year since the acquisition in kind of the holy crap, we got acquired, and we need to do things that make the parent company happy context. Oh God, okay, cool. One advantage, that is not my slides. This is David Coe, our CFO, and one of our software engineers, obviously instead of writing code, made that fantastic GIF. So an advantage of being acquired by a startup with a design or a bigger design staff is that you get a nice slide deck template. So here you got these blurry, like some bloom photos. You'll see some like bottom trail at the bottom. I'm gonna start a timer so I don't. Probably easier to look at my watch. Anyhow, so I'm a software engineer at Rally Health. So in Chicago, as the company that got acquired, we actually are on a .NET stack. So we run a majority .NET MVC with some jQuery stuff and some Angular on the front end. What we use for most of our logging is Splunk. So kind of our intentional logging is Splunk. If anyone's not seen the Splunk interface, I believe it's similar to Sumo Logic. You have the same kind of query syntax, so you have your search field, or at least, I'll start over. The main part of Splunk I'll talk about is the search app. So the Splunk engine kind of sits on top of a whole bunch of data, unstructured data, and the search part of it is the most used application. So I've got basically all the events that my application has logged, or all my log, and then search bar at the top. So what that looks like in our application code is we have a property injected log object, and anytime we log something, it's just log.message. In this case, it's a format, or it's a warn, and then we just have that message. So that turns into, via magic, of course, one of the principal skills of a software developer is using magic, oh, this is terrible. Oh my, contrast, Chester contrast when you develop slides. So essentially, we have our message down here, and we have the configuration of our logger that injects all of this metadata. So we've got our account identifier, which is a domain identity ID for that person. We have something about the host and information stuff. And I'll pretend that I knew that Brian was going to talk about the principles behind logging and piggyback off of that. So thank you, Brian. And I'm just going to talk about kind of how we use it. So that is really easy to throw into all parts of our application. Woo, yeah, let's throw that everywhere. Except this doesn't show the time frame, but this is about, I think I left that hanging for about 4 seconds, and that picked up about a day's worth of events, and there's 69,000. Obviously, this is an unlimited query at warn level, but that gets kind of noisy. And I basically just had that example because I had a Grinch, and I needed a GIF of that in my presentation. So I'll kind of take an aside to what our current, that was an older log that I wanted to show the exact logging code that translated to the exact same query. What we're actually starting to use now is a different logging library that actually in Splunk gives us structured format. So if anyone in the .NET world hasn't tried out Serolog, or if there's a different way to pronounce it, please correct me, that allows you, they have a kind of a special overload of the format string that takes in a structured object and spits out in Splunk. Kind of what you would normally take for granted, but traditionally, anytime we logged a JSON object, it would be a string object in the message field, which is not as easy to log and all that. So I guess these are kind of the lessons we learned from not having these things, I guess, is that it's really important to have exactly one environment, especially as you're adding more than 2 environments, and generally just more context around what you're logging. And so one of the parts of growing from I believe 7 full-time engineers last year to about 30-ish now working on the same team, and splitting up a fairly monolithic repo into smaller services that have shared endpoints, is that correlation IDs and being able to track a user clicks one button. I stepped on the cable. Best presentation ever, everyone said.
That's it.
Ah, cool. IT person included. So I'm a user. I shouldn't do that. I'm a user. I click a button over here. 9 services down, something else errors. I would like seeing that error at the end. I want to know what actually caused that. So even though one more image. Even though these services all track separate things, so the login service might say login time. If we were on a shopping cart, I'd have the items purchased. We want to keep the correlation ID a constant, so that if something happens in the shipping part of things, I can say, oh, well, the person logged in at 12:30, and obviously in our SaaS app, you can't log in at 12:30 because we're closed. Because some sites do that. The logging itself, we use a lot for just basically being aware of what's happening in our app. And if we need to investigate a production incident or performance things, that's easy to do because we know exactly what to search for, and we have probably more logs than we need. But another part of keeping a website up is alerts. So Splunk allows you basically to turn a query into an alert. So I will skip one slide ahead. For an example, we have our clock skew, and this is a query that essentially returns any results where the delta of seconds on a server from our single time source, that's let's say a definitive time source. If it's greater than 5 seconds, it'll show up in this search result. And essentially the configuration for this, you'll see, is that this trigger condition goes off if the number of results is greater than 0. And that runs on some schedule that we want. So maybe every hour or so or every day, we want to check if all our servers are out of sync. And then in this case, we run a script that sends a message to devs in HipChat. And then we have another script that if it's greater than some factor, it'll actually send out a PagerDuty log. Anybody in here use PagerDuty? What sounds do you guys use? Anybody have a sad trombone? That's a good one.
Can't hear it.
Oh, really?
It's quiet.
So we used to have all of our people that had pagers or PagerDuty use the sad trombones, and we have 2 separate offices. So we'd all go up. All the devs would go up to the kind of businessy office and line up for lunch and grab that. Anytime someone's in lunch and we hear a sad trombone, all the business people go, "Oh, what's going on now?" But thankfully, we kind of switched our logging strategy recently to be more kind of protective. So instead of prod is down, it's more of a prod's at 75% resource usage. So here are all of our, or I guess a subset of some of our alerts. So it's basically what we use passively to figure out what's going on. And obviously this is mission critical, this CB test. That's most important. Okay, so Splunk is what we use to kind of intentionally log things. I'm going to track, this is an important part, this is a key transaction in our business process. Let's always look at that so that if something goes wrong, we can figure it out. Raygun is a different application. It's kind of it's a agent that sits on our server, and it handles exceptions. And essentially, this is an example of an email notification, and the contrast is bad on this one as well. But it's essentially saying, here's a exception you've been getting, and these are not unhandled exceptions. These are just exceptions that are captured by some .NET lifecycle event that we can inspect upon. So the website is still working, but hey, by the way, you're getting these exceptions. So this is something that's happening a few times over the past minute. The current trend is decreasing, and you're getting about 3 per minute. So the interface kind of looks like this. You get a nice time graph of what's happening. You have in here your active ones. So this Canary app, oh, you've got 2 exceptions going with RabbitMQ, and then you can resolve them, saying you've taken action on them, or just permanently ignore it, saying, no, that's just RabbitMQ. It's fussy. So this has stack traces that you would expect to see in a stack trace while you were just debugging or in a log file. And then we have a little bit more of you have 3 instances of this exception. You can actually tab through and see the exact error details and all the metadata attached to each exception. So this is kind of a passive, hey, aggregate, these exceptions are happening a lot. Maybe check these out, maybe they're fine. And then New Relic we also use, and for now we've been using that more as a discoverability type thing, where let's just have an idea of what our application is doing. So this is one of our testing servers. So I promise that almost 2 seconds is not a production database query time. This is a tiny instance. So for one example, we've been doing some performance tuning as a result of our acquisition among security, remediation, and that type of thing. So one of the things that New Relic is really helpful with is kind of tracing bottlenecks. So one thing that's kind of hard to do in Splunk without knowing the query language, and who wants to learn another query language? I mean, I do, but not every developer has that initiative. But anyhow, so this kind of gives you an idea of like, hey, this is the bottleneck. It's obviously 5 times slower than whatever else you're doing. So you can kind of drill into that. So this is just a zoomed in view of that. You can click on that. And this is an example trace of one time that transaction, or maybe a representative time that transaction took a long time. So here we see, oh, well, this query took a long bit, and then it did another query. So it gives you some pretty low level insight into direct query without having to open SQL Server Management Studio or PG Admin or pSQL. And the nice thing about this is, as a healthcare company, we deal with PII, so they, by default, I believe, truncate or just obfuscate all data within the fields. So that's about all I have. Time is short, so if you have any questions, let me know. Thanks. Yes?
With New Relic, how is it usually just generated from logs, or do you actually have some sort of agent as part of the app?
That is an agent as well. Oh, I'm so sorry.
That's cool. So I noticed that you had Splunk alerts set around CPU, and you talked about clock speed and whatnot. Does that imply that you have something like dumping logs that say, here is my CPU utilization, or does Splunk have some sort of time series thing under the hood?
Those are Windows logs that we grab and send them to our Splunk instance, which is in I believe, a different VPN than our production services. Yes?
Rig New Relic, are they apps that are sitting on Splunk, or are they consuming data from Splunk?
They do not currently. They absolutely could. We could output some data from them. But we use them independently for now.
One more question.
Sure.
Have you explored using the HTTP event collector that was recently released in Splunk?
We have not. Well, we actually have in our applications, IIS lets you hook into application or IIS lifecycle events to where you can say, oh, you're beginning a web request. And then we actually do, using our logging library in .NET, we just do a regular log and say, hey, you're getting a log at here. And we treat it like a regular log with some different metadata. And then we can base it like, oh, this is a CSS file, or, and then we have the same metadata about the host and requester and all that. Yes?
You mentioned correlation IDs when I was saying like user sessions, sequence of events.
Mm-hmm.
How do you acquire, like, how do you choose that? How do you get a correlation ID and trace it and make sure that it stays?
So typically we just use GUIDs in the, I guess, originating app. That's actually kind of a work in progress because we don't have that across all the major key events, but our new services are using that in the ones they talk to. If that's accurate, I believe. It's in a thread context, I believe. So the thread that's running receives some request. Yes.
Does that flow all the way to the database layer then, or do you have some other way of associating a database call with a transaction?
So not in the way that I could tie it to something like that, what we saw in New Relic, but the calling code that has, we have a, oh man, what's a relational mapper? Not, thank you very much, ORM. So our calling code doesn't directly touch SQL, it's an interface. So I'll give Andy some time. But if you have any questions, hit me up afterwards. Thanks.
Thank you very much.
Hello, as you said, I'm Andy Peckys. I work at Signal, and we'll talk about how we do our logging. So first, who Signal is, and I'm not going to read this whole slide because it was written by someone in marketing, and they do all that kind of stuff. So, but really, in a nutshell, what we do is we enable customers that you see down there to work with their marketing partners without having to share that really valuable first-party identifiable information. So, you know, if I'm, Crate and Barrel, you do business with Crate and Barrel, they know who you are. They don't want to give that to whatever marketing partner they happen to be working with that particular quarter, right? So we kind of enable that through everything that hits their systems, hits our systems. We provide an identity store and let them basically let the marketers target you without ever actually knowing who you are. So that's in a nutshell what we do. So who am I? So I'm an ops engineer. That is my title. If you don't believe me, ask me for my business card. There have been a few people in here who already have it. So been in the industry for 20 years. I've worked at a couple of startups. I've been in finance, insurance, and trading, a few other things, and done all sorts. I just really like technology, so sysadministration kind of throughout, but development, security engineer, network engineer, whatever you needed. So current things that I'm working on, and that just kind of really like Mesos is really kind of something I've been doing a lot of stuff with. We have a lot of our internal tools kind of running on it, one just to, get our feet wet, know what works, what doesn't, and also just, why spin up, have these weird little random places where you run these little scripts that you need to kind of keep everything, kind of together, or little websites or little dashboards. Spark, Lambda functions, just dealing with data at scale, in general, that's what we do. So these are things that kind of interest me. So infrastructure, we're primarily an Elk shop. So I'm sure most people know Elk, Elasticsearch, Logstash, Kibana. Kind of like some of the other people here, we use our syslog as well as a transport. A few of the reasons we picked our syslog as a transport: one, it's already there. We're already using it to log files. So hey, why not leverage it to centralize our logs? To the socket, to the blocking question, one of the ways we get around it is we don't actually ever write to the file system itself. So it's writing, directly to the UDP socket through syslog. So we have our applications a lot of times writing directly to syslog, so they just are using that transport and using essentially a network handle and UDP to kind of avoid that. We also use it to tail files. So, some stuff still writes to files. That tends to be our lower throughput, kind of instances. So, the hit is fine. And like other people have said, really don't see it hit its breaking point until you're really pushing, tens of thousands per second. So, all right. So a little bit about our infrastructure. Dealing with about 1,600 instances, mainly Amazon, AWS, some rack space. We also have OpenStack in the office, and then, For our Elasticsearch infrastructure, 38 data nodes spread across 5 different regions globally. So, part of this is for redundancy. Our logs are important. We use them. We use them for a lot of different things. We use them for alerting. We want to make sure they're resilient, and that they perform. So part of the, the number of data nodes we have is to make sure that 1, we can process our write rate, and 2, still keep up a decent read rate. So we have dedicated query nodes, our ingestions, our log stash. And in general, that's our kind of run rate. As far as the question of what we're doing per day, we're probably in the 200 gig, or so per day. And, that's what we're currently kind of keeping online and searchable, as far as our infrastructure goes. And that can be anywhere from 30 to 45 days. Most of the stuff we need to do is not compliance related. It's mostly production infrastructure. We deploy every week. A month ago is 4 or 5 deploys ago. That data is not really going to be valid for what's going on now. So, we churn through our logs pretty quickly, and so, and we deal with a lot of them. So this is a little bit just kind of generically how we kind of set up the infrastructure. So the servers themselves are logging, like I said, either directly to syslog or they're logging to some kind of file system. We have hot proxy running on Logstash instances. We do round-robin DNS. This allows, maintenance of any instance. Either one of these instances can kind of take the load, but this way, if you have to, unfortunately with Logstash, when you change its config, you have to restart it. You have to reload its config. You want to be able to do that without interrupting anything that's going through. Another feature of our syslog, sorry, I should have mentioned it. Nice thing is it can back up. So if it senses that it's downstream, it's not available, it can back up locally onto the disk and then pick up where it left off. The thing you have to make sure is you set that in your syslog config, so it's not there by default. So we have our hot proxy instances running Logstash. This is where we do a lot of things. Now in general, for our applications, and I'll get this in a later slide, we try to log in JSON. So there's not a lot of transformation or mutation that we have to do. Less we have to do, the better. But we don't get to write everything that we use. We have to deal with a lot of just different structured logs. So Logstash enables us to parse, change, transform, discard, whatever we need to do. So as much as possible, we try to filter at the server layer. You don't want to put it on the wire if you don't really need it. But, sometimes you don't really have a choice depending on the logging level. So that gives us another place where we can, do those kinds of transformations. And then at the end, we push it into an Elasticsearch that we referenced with Kibana. I didn't add it to here, but we also have a few other things that we leverage that Elasticsearch cluster for. So not just our log data in Kibana. So like I said, things to do to make logging easier. Log in JSON. So much easier. Standardize your logging format, for our applications. When we first started doing this, every little team is writing their applications and they call it different things, or maybe they camel cased it, or they put an underscore or a dash or whatever. Have those things there, publish them, put them in Git, give them, snippets, libraries, skeletons, so that, hey, just add this and it's just done, because you don't want to be spending cycles on just like, oh crap, they just do it slightly differently than we do it over here, and now we have to make that allowance for it. So, and then, like I said, don't log to a file if you need the speed. Just get it right on the wire. And then now to the things. So I didn't really do too many slides. I was actually going to just show you a bunch of the dashboards and stuff that we put together and kind of go through some of the things that we do on them. So we'll start with this guy here. It's not quite as nice. So one person asked about how do you monitor that your logging infrastructure is working? Well, this is how I start to monitor that my logging infrastructure is working. So, I watch my ingestion rates. I also watch my message distribution, because sometimes, even just looking at this, there's a pattern and you can see it. When you're doing it across long times, it gives you that ability to oh, there's something different there that maybe gets lost, when you're just looking at it in a big line graph. So this is something you'll see a lot in the views I do. And then just what's my breakdown? Where are my top talkers? What are my, what kind of messages am I looking at? And then, give me the ability to kind of drill down and sort, by the things I need. And actually, I think I actually hit sort on something there. So yeah, and then, get down to the details. And then, so this is something that, again, like I said, we have Elasticsearch. We use something called ElastAlert to basically be querying Elasticsearch. I have it running in a Docker container. It's running all the time, making queries on whatever interval I need, and looking at different metrics. So for my log ingestion, I'm looking at like standard deviation. Like, it's always going to be a little, this. But when it really gets really up or really, really down, this is when I need to know about it, and we want to do something about it. So that's the first step. Move on to now getting into the application layer. So, similar kind of, you see a similar kind of setup. What's my app doing? And again, you can see that when you have certain events and you look at it in this kind of view, you can see that, okay, yeah, these events kind of propagated. And when I had this, I got a bunch of them all at once, and that signifies this. Okay, I can go look at this. Maybe it's okay, maybe it's not, or what's going on here. And then another thing about application logs, when you're logging in JSON, when you're logging in general, and if you're going to be using Kibana has a lot of nice functions. It can do math on your stuff. It doesn't really do math very well on a string that's a number. It just doesn't really work. So, make sure, if you're using Logstash, if you have control over the application logging, make sure your numbers are numbers. And then you can do things like take those numbers and sum them and aggregate them. So, this particular, these views here for our flushing and archive and formatted messages, well, there's thousands of messages that make up those numbers. And I can't add them together if they're not numbers. So that's, just pro tip. Those are good things to do. Let's see, security. So one of the things we do is we're in Amazon. So we're ingesting CloudTrail. So Logstash, really nice, has an input from S3. Use CloudTrail files, go into S3. It's really, really easy. So I ingest from S3, I pull in, I set into Elasticsearch, and now I can start seeing like, hey, what are my events? What's going on, in our APIs with my keys, what regions, where are things happening, and it's really easy. Like this particular integration, we kind of thought about it and we're like, hey, I wonder, and it really took about 10 minutes, for us to get from, hey, I wonder if we could do that, to, hey, wow, that's kind of cool, we got data, and so, those kind of prototyping, by using Logstash and being able to, just put it into Elasticsearch, really just made this kind of stuff very easy to do. That was AWS security. Getting into physical security, same thing. We're using syslog. We're logging syslog events. All this stuff is already there. Most of this stuff is flying on your servers all the time. Some people look at them. Most of them don't. So take advantage of this and use it because you get it for free. Logstash has built-in syslog parsers. You really don't have to do anything. It'll parse the message, it'll turn it into fields, and it'll let you do the analytics that you kind of need to do. So. Other things. This is an example of what we're doing, and it doesn't really, it looks a lot better. Wait, let me do this. Yeah, there we go. It looks better when it looks like all like that. So, example of parsing like Apache logs. So, what are my, queries, what's getting hit, what are my response codes, and, what are my latencies? So, being able to get this information and have that reflex, and then being able to dig down when you have an issue, like, really, I shouldn't have any of these, so, and actually probably after this, I'm gonna be clicking on that button right there and seeing why I have those. So again, just an easy way. This is an out of the box. The Logstash has grok patterns to take these data and turn it into easily parsed fields, and then you can also write your own grok filters. So you can put this stuff together, and it may be a gnarly regex that's huge. Oh, but when you're in Logstash config, you just say, yeah, hey, I want to parse the thing, because that's my name for the the thing. And you can do all that. So, allows you a lot of flexibility, to really get your data into the format that's useful to you, because if you just shove data in there, it's not going to be useful. It's going to take forever to search. It's not going to be, and in the end, you have someone with a whole big thing of text. Like, great, what do I do with this now? So you want to, make it, intelligent and in a format that can use. I don't know if anyone out there uses Graphite. Graphite users, yeah, so another nice thing, if you're using Grafana, we have, I'm taking my metric data that I'm pumping into Graphite, and I'm taking my log data that I have in Elasticsearch, and I have events. So now I can see, I'm like, hey, what are these? If I'm looking at my graph, like, hey, what's that? That doesn't look right. It's right here and it's right there. It's not right there. Oh, wait a minute. Somebody did something. Take a second. Oh, the live demo is always the worst, but you saw it there. I have witnesses. It was there. Let's do this. I got to do this. There. Does it go back? Does it go back? Yay, please. No, yeah. Live demo, always the worst. All right, so moving on. So that was all Kibana 3. So now they do have a new version, Kibana 4 out. First off, I'll tell you part of the reason why I don't do a lot in Kibana 4. One is because it hurts my eyes. It's very bright, and then they're putting the dark theme back, and I know it's a personal thing and it's weird. I'm a troll. I work in a cave, and this is really, really bright on a big monitor. But it does offer a lot of nice things. So they moved to an aggregation framework. So when you're putting back a lot of data, Kibana 4 makes it a lot easier to pull back that data because of the nature of its aggregation framework. So right now, I'm looking at some MongoDB performance as far as like how much I'm putting in. Hey, where are my outliers? My 90th percentile. Like, why is this query taking so long? And why did I have so many of them take that long? And building in and again, giving, the developers a way to easily drill into this data and see, it's like, okay, I can click on this, filter by it, filter everything else by it, and then now get at this message, right? So, it really allows that the same kind of drill down for, to give people the information that they're really looking for. And then, nice thing about this too is, this is all, virtual. You can build this whole dashboard. I mean, I guess the only kind of sort of other complaint, literally that whole dashboard is built in the URL. So you can take this, publish it wherever. The only recommendation I would say is don't post it in a hip chat because it breaks. All right, other things that we do with our data. So this is GeoIP data. So we have a lot of stuff coming in. We have all this data coming in from everywhere. Hey, sometimes it's good to know where it's coming from. And then, little breakdowns of like, hey, breakdown by country. Like, here are the big countries that are doing it. Hey, is everything working? Yeah, we got mostly 200s across the board, except for here, and that's another one that I have to look at. So again, allow you to visualize the same data. This same data I use to drive my, come from Hot Proxy. I'm using the same data in, 5 or 6 different views and different presentations to give different people what they need. So again, the flexibility of it is great. And then this is a kind of a last one. This is a Kibana 4 representation for web monitoring. How much am I doing? What are my top requests? What are my top requests by response time? Like, how long are they taking? How many am I getting? When, what's going on here? Why is those things taking so long? So again, it's just taking that log data that previously had just been sitting and someone might look at when they had an issue, and they might take them a few minutes to find out which server of, the 1600 that they had to find it on, or it wouldn't be 1600, it would be several hundred. That's a little easier, a needle in a pile of other needles. But, so, being able to aggregate this and then not just take that log data for an error and say I have an error, but the number of errors is a metric. The content of that error is a metric. Taking the contents of the errors and turning it into other useful information, you're kind of getting it for free. It's already there. Use it. And then I think that's about it. Let's see, did I have any other slides? That's all the things. No, and that's us, and that's the building I work in. So, yes. Yes, so if anyone doesn't know, Signal, we took over Braintree's old offices. So they're not as big as this, and this is, I really like this is very nice. But considering we were like in a shoebox before, there was like 50 of us in a room that was half of this big. So, the old offices are very nice. We thank you. So anyway, thank you. We do including certain things. You know, so for, you know, there's some of the security stuff, like I'd already logged in and provided some of the stuff, so you didn't have to see all that, you know, rigmarole. Yeah, so we do authenticated access to some of it. Some of it is really, it's not that, you know, I mean, we have, you know, tunnel store offices and stuff like that, so it's locked down by ACL. So in general, at least for our stuff, there's not very, you know, that's not where the really important data is, right? So the log data that we have, there's not really a restriction as much to it. Now the security data part of it, what's going on in Amazon, what's going on in the boxes, you know, who's doing what, and then anything that involves like the proprietary, you know, the first party data, you know, that has its own separate things that don't tie into this. It's, they've got their own controls, so.
With Kavana 4, are you using 4.1?
I'm using 4.1, yeah, because I'm on 1.7 for Elasticsearch, and I've got 2.0 in dev, and I'm using 4.3 for that.
So with Kavana 4.1, it's periodically when you run for an extended period, sometimes goes into a bad state where it shows the no living connections issue.
Yep.
How are you working around doing that?
You know, some I'm doing, you know, the old, well, you know, every once in a while it hits restart, you know, whatever. And then for some of it, a lot of our, as far as driving our dashboards, I have not found that problem when you use the embedded dashboards. I find it when you're using the full stack. So for some of our dashboards that are running the TVs, I use it embedded, and then that way I'm gonna get home and stuff's gonna be broke. Yeah, so far I haven't had that with the embedded links. So.
Do you ship anything from Logstash or Elasticsearch cross-region?
Not specifically. Each Elasticsearch cluster is its own region, and then we federate back to our office. So, you know, query-wise, sure, but not actual replication between offices. I mean, so far, we do that with Cassandra, and that's enough. Cross-region replication in Amazon is, in theory, fine. In practice, not really a great idea. So. Yeah, and that's what I do. Yeah. So, although I don't always, because again, hitting that tribe node, you know, going across 5 different regions, there are times where that makes sense, and there are times where it makes sense to go directly to a region when you're doing it. So.
So first of all, I want to applaud all the presenters on doing some pretty creative things that I think are probably in the top 10 percentile in the industry. So, congratulations on that. However, I've noticed a trend from everybody. It's kind of what's going on today or less than today. Is there a vision to start looking at patterns that are week, month, year long, where a human really doesn't have an interface to that? You depend on intelligence or analytics.
That was the first part about you.
Yeah. Have companies approached you with this, and the solutions just aren't there? Is the technology behind your systems too dynamic to track trends that long?
For some, yes, but for some, no, and that's where, you know, for me personally, that's where Spark and some of the other stuff's coming in to allow us to do mining of that broader data set. So, you know, for example, you're right, a lot of the stuff that we do tends to be reactive. I mean, in general, we're ops. Shit breaks, you got to deal with it, right? And you need to know when that happens. That's the first part. But, you know, that trending out of, you know, hey, what is our long-term view of this? You know, we have, you know, and like a lot of us, we have some metrics that we store long-term, but for us, dealing with the amount of data, trying to store that much, you know, long-term isn't really feasible. So that's why we're looking at things like, you know, Spark to essentially take that fire hose, make those aggregations, you know, and feed, you know, whether it be a machine learning or, you know, another data store. And that's actually, funny enough, we have a hack week coming up. We have hack weeks and shark weeks, like kind of after every season, where we get to like, hey, it would be kind of neat to do this. And actually, that's one of the things we're looking at, because I run the Mesos cluster, and we're looking at a Spark framework on Mesos to start just basically ingesting that fire hose, and for some of it, just to see, you know, like, are we seeing those overall patterns? Because I can say, when I did the same thing at the trading company I was at before this, I found hotspots of data and things that I never would have if I hadn't looked at it like this, you know, because it was always like this.
One of the theories out there is take snapshots and look at the snapshots instead of that whole historical data. But yeah,
Yeah, well, and that's what we try to do, is like take those aggregations and get those things and find those counts at least, and then have at least some of that data persisted, and then with the new S3 prices, you know, it actually becomes a little bit more feasible and all that kind of fun stuff, so anyway.
One more question?
Can you talk at all about your use of Elastalert? I haven't heard of that.
Mm-hmm.
You don't have any alerting on
Yeah, so we were using it because now they have Watcher, you know, is like kind of their pay-for product if you have support and stuff like that. But we just kind of had a need for, like, hey, we were getting all this log data into Elasticsearch, and it's not really used for logging, like alerting on, like, hey, I saw this one message. It's more like, hey, I just saw 50,000 of these in the last 2 minutes, and that's not right. You know, you've crossed this threshold, or you know, whatever. So what Elastalert does is it makes those queries. It's a GitHub project. You know, sort of, it's on GitHub. We run it in a Docker container with basically a set of rules in YAML to say, you know, I set up my query. You know, it can be an aggregation query, it can be a count query, it can be a full query. I mean, it can really be whatever you want. Anything that you can query Elasticsearch for, you can put into this, and then have rules on it. So whether it's email, do something else, repost, you know, do whatever. So, you know, we're keep using it. Watcher does a lot of the same things. Watcher runs on the server, you know, where this is kind of like an external querying in. So that's like probably the biggest difference. But you know, that's about it, and it's really handy for spotting those big trends, or for, you know, getting a little bit more intelligence, you know, out of those alerts. So,
Thank you very much.
Thank you.
Hello, everyone. I know it's been a long evening.
Use the mic.
Hello. Better? I know it's been a long evening. Hopefully I shouldn't take much time. I'm Jayesh Thakrar from Conversant. About 3 years ago, we were known as the Tommy, but we changed our name, Conversant. We've been acquired twice in 4 years, so we might change our name again. So who is Conversant, or what is Conversant? We are in the internet ad space business. We do programmatic ads, so basically there are ad exchanges out there, and we bid for ads and we send out ads to people. But we have a couple of key differentiators. We send ads to targeted people, not to just any Tom, Dick, and Harry, because we don't get paid by impressions. We don't get paid by clicks. We get paid by purchases, or you know, how much people buy. So that's one thing. And the other thing is, we not only know about your online activity, but also your offline activity. You know, that's our secret sauce, basically. Okay. And who am I? I kind of get to play with big data toys. You know, I build Hadoop, Kafka, Storm, and all that, and get to play with them, monitor them, and you know, try out different things with that. Okay. So what am I going to talk about? It's about a data pipeline that we have today. We call it Cadence. And it is used to transport application log data from our remote data centers. We have 4 data centers, one on the East Coast, West Coast, Europe, and Chicago. And what we do is we have applications running on those remote data centers, and we bring log files from there into Chicago with a volume of about 90 billion log lines a day. And we expect to grow more next year. And as part of the data pipeline, we use Storm, Kafka, Hadoop. I won't go into the details of that because it's a little bit more involved, but I'll just kind of brush over of how we have kind of plumbed together the whole pipeline, and what do we do, and how do we keep it up 24/7 and things like that. Okay. And we actually had a talk on this in 2013. One of my colleagues, he did a talk on this on the first iteration of the pipeline, where our target was to kind of process 20 billion log lines. And today we are 90, and we'll go higher. And Mike is also going to do a hands-on tutorial on Flume and Kafka and Camus in November. I have some details in my slides. Okay, so here's kind of how our system looks like. You know, we have ad exchanges, websites, users, and so on, and logs flow from the remote data centers to Chicago. Okay. And in in each of the remote data centers, we use application building blocks to build or to scale our applications. So how does a building block look like? So we have an application, and that application would have an embedded Flume agent. So the application sends all log data to the Flume agent. It's like, when you have your log4j or whatever you have there, your sync for the log4j would be either sysout or whatever you have. In this case, our applications, they emit out to a Flume agent, which is part of the application. And you can configure Flume, or actually, you can configure Flume to send that data somewhere else. So the agents within the application, they are configured to flush their log every 1 to 5 seconds. It depends upon the application. Some applications they emit too many log lines, so they emit every second. Some of them do it less they have less data, so we configure it for 5 seconds. You can configure it by time or by number of log lines. And so we have both those thresholds. And then what we do is the whole set of log lines from that embedded Flume agent becomes an event. It's like a log event. But that log event has got multiple log lines. That event is then sent to another Flume agent in the same data center, same subnet, same rack. And that Flume agent takes in all the events, and then it would compress that and send it downstream. Because we can't afford to have the bandwidth consumption with uncompressed data. Okay. And then what happens is, from the remote data centers, the data comes to Chicago. And in Chicago, we need to make sure that our data, we don't have any duplicate events, because we get paid by the number of impressions that are linked to certain sales and so on. So we need to make sure we don't lose data, nor do we over-report our data. So what we do is, every time we get an event, we look up HBase and say, hey, have we received this event? If so, drop it on the floor. If not, then make an entry in HBase and then pass it on forward. Okay. What happens next? So then, that data from that Flume agent is fed into Kafka. And I'll explain as to why do we have Kafka in the system. But the data is sent to Kafka, where the data can be there for a couple of days. It can be retained there for a couple of days. But the thing is, once it's there, we pull it out on a periodic basis using MapReduce jobs. There is a framework called Camus from LinkedIn, and it's very well linked to, or it's very well integrated with Kafka, and you can pull out your log data and dump it into HDFS. The reason we have Kafka and not Flume writing to HDFS directly is because the volume was so high, the name node of the HDFS was having a very hard time in keeping up with the flow. What would happen is, every event that we send from the application was from a few hundred to a few thousand lines. That event would become a log file on HDFS. So, we would have tons of log files being inserted into HDFS, and it was hard for name node. With this structure, or with this architecture, what we do is, Camus will pull out all the log data and then just save it as a couple of few files on HDFS, further reducing the number of log files. Okay? So that's basically what we do for our data pipeline. Now, as you can imagine, there's a lot of data flowing back and forth. Things can go wrong, and you need to keep an eye on the system. So for that, what we do is we use OpenTSDB to collect data from Flume agents, from Kafka, from Hadoop and everything, and put it into OpenTSDB. That's a monitoring solution. And that data, it's not very pretty, so then we use Grafana as a front end for that data. So here are a couple of charts that we have there. So here, we are monitoring the, how much of the backlog we have in the Flume channels. So if we have any kind of network outage, you will see the Flume channels kind of filling up. So like, for example, this is East Coast, West Coast, and Amsterdam, or Europe. And see, kind of, you can see a big spike there. But again, it's not something that kind of, that is alarming, so it's okay. And here kind of we have the event rates. So we have 5,000 files or events coming in from IAD or from, I'm sorry, 5,000 events coming into our Chicago data center, those going into Kafka, and that's the Flume event rate by data center. Okay. And here's kind of how, so in Chicago, Flume and Kafka are both running on a single set of machines, 30 machines that we have out there. So we are running both of them, one on top of the other. We had kind of sized the machines only for Flume and not for Kafka. So we put in a lot of kind of system load on the servers, and kind of we have kind of probes making sure we don't have any issues with that, because Kafka does data replication, or you can do data replication for safety reasons. So kind of we keep an eye on the I/O, the network, and so on. So that's the system load across 30 machines, and it's a sum actually some of the uptime number. So it's always say below 25, 30 across 30 machines. So that's kind of nearly zero for us. And that's what we call a snapshot onto our Hadoop cluster. That's the number of vCores we are using on one cluster. That's the other cluster, and the vCores, the memory being used, CPU load, and so on. Okay. And the vCores and the memory kind of we have a breakdown by the yarn queue, so kind of we can know exactly who's consuming how much CPU and so on. So we can scale back any application if it kind of overruns the system. That's basically it. So yeah, so I mean, do we have time? I mean, I can just kind of quickly brush through this. So yeah, so when you use Flume, Flume doesn't have a master or any kind of central controlling system. It's all peer-to-peer. One agent sends data to another, and so on. And each agent has got 3 components inside. The source, where the data comes in, a channel, where the data can be saved to disk if you want to, and then a sink where actually you'll send your data out. So we have agents with multiple channels and sinks kind of configured to allow us to kind of bifurcate data, send the same data to multiple clusters, like we send data to production and a fraction of it to our QA environment, kind of for continuous regression of the data. We use something called a selector within the channels, which actually will allow, which can introspect the event headers in the Flume, in the Flume events, and say, hey, where should that message go? So we use that capabilities here. The data that comes into HDFS, we aggregate on that, because that's kind of the living dashboard for business, because kind of they need to know how much money we are spending on ads, how much like we have caps on campaigns and all that, so we need to make sure we don't exceed our campaign limits and so on. And then we have kind of end-of-day checks on the data that we land. So at the end of the day, we make sure we run a job to pull out data or to scan data for the day and make sure we have not missed data from any server. Just in case a server had died or whatever, you won't get its data. So that's how we kind of check for any issues there. And the data that lands into HDFS, it goes into a Hive partition, and depending upon the log type, the Hive partitions may be retained or archived or purged, depending upon the file type. Like some data we retain forever, some data we retain for 7 days, some for 14, 30, and so on. And the last bullet point, we have monitoring of the Flume channels and other things from the data that goes into OpenTSDB. So we just kind of scrape the TSDB monitoring data every 10, 15 minutes. And if we see any channels being filled up, we send an alert out. So that's what we do for monitoring. That's the presentation. I think there's a presentation being done by Mike sometime in November. That's the link for that that's the link for the tutorial there. Any questions?
So for your Kafka, how many partitions do you, like, are Kafka boxes all essentially one big Kafka cluster, and then, or do you have topics kind of like these, 10 servers have this topic and these 10 have this topic, or like, can you explain how you kind of break that out?
Sure. So the whole set of 30 machines is one huge Kafka cluster, and we have created topics, kind of per log type.
Okay.
And we have kind of had a rule of thumb as to say, if you've got so many million lines, have so many partitions and so on per log type. The Confluent.io people and the people who kind of invented Kafka and LinkedIn, they recommend hundreds of partitions, but the biggest partition that we have is, I believe, 35 or 40 partitions, where in that log type, we have about 30 to 40 billion log lines in a day. So we have undersized it because.
That's why I was just kind of wondering, because like I've seen those same kind of things, and we use Kafka for a lot of our production stats data, and it running the same thing. It like didn't seem to help us by drastically increasing the number of partitions. Like our ingestion rate like wasn't really that much better, and stuff like that. So
I think he had a question there, and he was there. Sorry.
How do you manage Zookeeper in your topology? Are those on dedicated instances, or do you have those co-located with some of the management systems for the Hadoop cluster?
So for the Hadoop clusters, we have got dedicated management nodes, but for Kafka, because we only had 30 machines, we didn't have the luxury to take out servers for Zookeeper. So they are shared among the systems, so we are fine.
So in my world, deduplication at the pro or agent level is a big deal. Have you explored that, or is that something that's technically not feasible in your environment, of the deduplication that you're doing in Chicago?
We have thought about it, but we haven't found a way to do it very easily, because your sender might say, I have sent this data successfully, but it may not have got the acknowledgement from the first hop. Or the first hop might have received the data, but the second may not have received the data. So we want it to be done at the final hop and make sure we have got the data,
How do you handle configuration of these distributed agents? Like, if you want to add a selector to...
So initially we did it by hand, but kind of it became very, very unwieldy. So we wrote a Python script to kind of just automate the generation. We would say, okay, you are server number X, and your targets are A, B, and C. Go and generate all the files for all the log types, and boom, we're done. So it's.
I'm interested in the deduplication phase. You write down the H phase. Is that like an at least one type, or is that guaranteed to be one? It's guaranteed?
Guaranteed to be one.
Do you have like locking on top of HBase to get to that?
No, so the thing is, the way HBase works, all your raw key data, kind of goes to a single server. So that's the only one who needs to keep track of that. So we first do a check of that row. If it's there, it's a duplicate, and we drop it down. But if it's not there, we write it, and then we let it go, and anybody else who comes in next will find the row there. Now you might say, hey, what if two servers receive the same event at the same time? That's possible, but we haven't had it so far. It's like the same, because the sender will always send it to one destination. So that's highly unlikely.
So I remember seeing Mike's talk in 2013, and it's interesting to see how the architecture's evolved with the introduction of this Kafka layer as a sort of buffering tier. If I remember correctly, the deduplication with HBase, he had that in 2013. That only works, I believe, because you guys were using the MapR implementation, because otherwise the writes on regular HDFS back to HBase wouldn't keep up. So that's something to think about. But because otherwise the writes would just kill your HBase, right? But in your tier
So so technically it's the hop before, before we put it into Kafka.
Okay.
So the data in Kafka we know will not be duplicated. That we know. Okay. On the Hadoop side, we use the Camo framework, and what it does is after it pulls up data successfully, it puts a checkpoint somewhere. Like so, we put it on an HDFS file. So that guarantees that we'll always start from the next event. So we know we'll not pull it twice. So that's why. So the Flume agent kind of is our last hop.
I misunderstood the background.
Okay. Any more questions? Thank you.
Thank you to all the speakers. One thing I did forget to mention earlier is Brett Slasky is starting to explore having a Northwest Suburbs DevOps meetup. So if you're interested in that, it'll still be part of the same meetup group, but just happening in the Northwest Suburbs. So something to watch out for. What's that?
Are they thinking Schaumburg, or?
I don't know. I think they're looking in that area as much as I know, but I know they're definitely looking for some speakers to start it up. It'd be interesting. So if you're interested in speaking there, please let me know. And here as well. I mean, definitely we're always open to new ideas. So thank you all for coming.